Hi everyone, my name is Emily and today we're working on an ionization energy problem. So let's start by defining what ionization energy means. It is the energy required to remove an electron from the valence shell of an atom. So whatever atom has higher ionization energy, it means that it is harder to remove that electron. You have to put in more energy to take that electron away. Now in this problem, we're comparing the first ionization energy and the fourth ionization energy for sodium and sulfur. So the first ionization energy means we're removing one electron. The fourth ionization energy means we're removing the fourth electron. So we've already removed three, we're going to remove another one from the atom. So we are comparing sodium and sulfur. And let's start by answering the first part of the question, which just asks about the first ionization energy. If you look at your periodic table, you will see that sodium is actually a group 1 element, and sulfur is one of your nonmetals on the right side of the table. And since sodium is so close to having a noble gas configuration, by just losing that one electron, it's going to obtain it. So it's going to be a lot easier to remove one electron from sodium, from the valence shell of sodium, than it will be from sulfur. Sulfur has a higher Z effective. Once again, Z effective is the effective nuclear charge. It has a lot more protons. The electrons are more attracted to the nucleus. So it's going to be harder to remove an electron from S than it would be from N. So the ionization energy, the first ionization energy for sodium is going to be much less than it would be for sulfur. So it will be easier to remove one electron from sodium than it will be from sulfur. And by doing that, Na is going to have a noble gas configuration. To answer the second part of this problem, let's go ahead and write the electron configuration for sodium and sulfur. So sodium is going to be 1s2, 2s2, 2p6, and 3s1. Sulfur is going to have a noble gas configuration of, noble gas of neon, and then 3s2 and a 3p4. So if we are comparing now the fourth ionization energy, so we're going to remove 4 electrons. So the first electron for sodium is going to come out of this 3s, and the next 3 are going to come out from this 2p. Whereas for sulfur, the first one's going to come from 3p, and the next 3 will also come from 3p. Now if we do that, we actually lose all the electrons in this guy. So we're just left with our 3s2. But for sodium, remember, after the first ionization energy, sodium is going to have a noble gas configuration, which means it's really stable, and it would hate to get rid of any more electrons. So it's going to be harder to remove electrons past that first ionization energy. We are also taking them from this 2p6, from this 2p orbital. So that's also going to make it tough because we're unpairing these electrons. So when electrons are paired, they're more stable, they're happier, they're in a lower energy state. So it would also hate to, it would be harder to remove those electrons from the outer shell because you're unpairing the electrons. So for the fourth ionization energy, it's actually going to be harder for sodium. So you're going to have to put in more energy to remove the fourth electron from sodium than you would have to put in to remove the fourth electron from sulfur. I hope this made sense. If you still have questions on it or something is blurry, please come into my office hours or attend the workshops on Wednesdays. And have a great day. Thank you.